Oh, hello. You're here for the exponentials? Great. Let's learn how to solve them. Now, this is the first way to solve exponentials, and to be honest, it's the easiest. We want to get like bases. This is how you can solve exponentials that can get like bases. Now, we'll see eventually where sometimes you can't, and we're going to deal with logarithms, but that's a nightmare for you for another day. Now, first up in the docket, I said you have to get like bases. Like bases. So when I see 9 and 27, I'm running through my head, what number could be presenting both of those as a power? So hopefully you start to think 9 is really 3 squared, and 27 is really 3 cubed. So I'm replacing 9 with 3 squared, but the original exponent's still there. I'm replacing 27 with 3 cubed, but the original exponent is still there. So notice what we have now. The power-to-power property, we have 3 to the 6x equals 3. Distribute here, be careful because it gets multiplied by the entire power. We get a 3x minus 9. Now notice something. If they both have a base of 3, and we're claiming these two sides are equal, then their exponents have to be equal. Didn't want that marker anyways. We're left then with only the challenge of solving the exponents. It's a really nice property that when it works, it's wonderful. You can get like bases, set their exponents equal, and now we're in Algebra 1 pre-algebra time. Subtract 3x, x equals negative 3. It's pretty nice. The toughest part of this is finding a way to get like bases. So let's take a look at another one. Now, 4, right away I know it could be 2 squared. Right away I know it could be 2 squared, but I'm going to wait. I'm going to wait to see. 64. Now to be more specific, it's 1 over 64. So there's going to be a little trick we use here. Now in my mind, I know that 64 is 8 squared, 4 to the third, or 2 to the sixth. Now I want to be intelligently lazy. Select one that's going to make you do the least amount of work possible. You realize that I can keep this a 4 as long as I choose that? So I'm not going to go to the 2s, I'm going to stay 4s. So watch my transition here. It's really 1 over 4 to the third equals 4 to the 2x minus 1. How can I get this with a base of 4? Well, think of this. How did it get to the bottom? It means it must have been a negative exponent at one point. So before I'm allowed to set this up, I have to manipulate it, and now they have the exact same base. Notice when you have a fraction, you might need to get a negative exponent in order to get like bases. I've accomplished that. Game time. I set my exponents equal, and I'm solving. Add the 1, x equals negative 1. Clean and simple. Last one. It has fractions. Long bell. Here we go. Do not freak out. Still think. 4 and 9, it should jump at you. That's 2 squared, that's 3 squared. A lot of people look here and they go 4 squared and 9 squared. Not debating with you. It is. But if we make this 4 over 9 and that 2 over 3, it doesn't make sense. So you see we have options here? You can either make both of these into 2/3 or one of them into 4/9. Be intelligently lazy. I'm going to keep this 4 over 9 to the 3 minus x. This I'm going to make 4 over 9 squared, which is still being squared. Does everybody recognize this is represented by the innermost and the squared is still waiting? So I'm going to make my exponents equal. 3 minus x is less than or equal to, I'm going to do mental math here, 4. Almost done now. Subtract the 3. Divide by negative 1. Ooh! Anybody notice that I changed it on you? It's no longer an equal sign, it's an inequality. You divide by a negative, flip the sign, you want to equal to? Boom, right there. It's okay to be impressed. We're left with x greater than or equal to negative 1. Quick, easy tutorial on how to solve exponentials when you have like bases. Walk off.